housekeeping things. This event is being recorded, so it will be available on the CAPA website under the RMAEC tab, archived webinars, and it'll be available, I don't know, maybe first of the week. We'll see how fast I can get it put up there, but we'll get it done. I want to apologize to all of you that were on last week, and hopefully you got the copy of the slides that I sent back out afterwards. So before we get going with this presentation, I want to thank our sponsors, all those that help to keep this at no cost. CARS, the Colorado Association of Road Supervisors and Engineers, MEGPEG, APWA, Federal Highway Administration, Benvix Technologies, A1 Chip Seal, Vance Brothers, and Cassie as Schmidt Construction. I want to thank all of them. I don't have their slide up today, but just going off of memory there, I want to thank them. If you have questions as we're going along today, go ahead and chat them in the type them in the chat window, and I will try and keep an eye on that window, and we'll go through that as we go along. Fighting a bit of a cold here today, so I sound a little gruff, but that's the way it is. It's that time of year. So we're going to be talking about asphalt compaction today, and the importance on compaction and the focus on quality. So we're going to talk about these are the agenda for our session today, and we'll go through these in some detail. I'm hoping to have this done, wrap this up, in a very short time, in about an hour or so. So we'll get that. There's a gentleman that used to be in our industry years ago. He passed away. He has passed away since then. His name was Chuck Deal, and Chuck was known as the godfather of compaction. And this is one of the things that he impressed upon me at one point, was that compaction is the last chance to get your density and your smoothness. And the other part of that was, and I don't have that in here, but compaction is the single most important factor that will ultimately affect the asphalt itself. And if you can get compaction, even if you're fighting other problems, you're probably going to have a road that's going to last. So questions you ask are, is this a support issue, or is this something else? Well, the short answer to that is it's something else. That was a subgrade failure, but it was caused by some other influences, such as moisture rolling across, running into that ditch, and causing those. This is a fatigue problem. Fatiguing can be caused by a couple of different things. It can be caused by overcompaction on the front end, but it can also be caused by lack of maintenance on the back end. Wrong mixes on the wrong roads. I have some pictures of some roads that were over-designed or overbuilt, and they cracked out just like this within about 2 years. So so we want to make sure that we're putting the right mix down on the right roads, and then we're compacting it. This was an overlay on top of concrete, and you can see the blocks. If you look where the cracks are, they're right exactly where the joints are. So that's reflective cracking that's coming back through that concrete. It's hard to see in a picture like this, but there's a lot of segregation in that picture. That can be a big problem for compaction, but it's also a big problem for the long-term life of the road, allowing that moisture and oxidation damage to occur, which will deteriorate and lessen the life of the road. So those are just a few little tidbit slides that I put up in the front, so we had a little bit to chat about as we get going. So the real question here is, what are the goals for compaction? And the goals for compaction are to maintain the grade and slope and the profile that the paver left. The paver is a very sophisticated piece of equipment in today's world. We want to make sure that what we're doing on the back end doesn't affect what we did on the front end. We talked a little bit last week about placement and all the things that go on with placement. So this presentation here, we're going to talk about how to maintain that. So there are a few things that we want to talk about, and that's passes and coverage. There's a lot of discussion about what is considered a pass. Passes in my mind, are every time that the roller completes a loop, in my mind, is a pass. So if it goes down and back, that's one pass. Down and back is two. You can see in the illustration here that they're saying that a pass is down once it passes you, and then passes you again and passes you again. Those are passes. Those can be debated and talked about for long periods of time. But for my illustrations, let's say that a cycle is considered a pass. The goal is to get the material compacted with the least amount of passes to get the density required. Want to apply the lowest amount of compactive effort to get the highest amount of density. We have to understand how the material compacts. It compacts on a curve. It will get to a certain point where it reaches its maximum density. And if compaction energy is still being applied, it will start losing density because it'll start breaking apart the particles, and you'll lose density in the mass. So we want to make sure that we're not over rolling it, we're not under rolling. We want to be right in that sweet spot to where the material will get us right into that yellow zone on my illustration there. We want to stay in that. We want to make sure we're in that illustrated area. There are a lot of factors to being the material compacted. You can look through the chart here. I've got all the arrows that are pointing different directions, that are going different places. But the first thing is the intimate particle contact. We want to make sure that the particle contact that is happening behind the paver will stay there, and we keep it intimate. All we're gonna do is we're gonna make it tighter. We're gonna move the particles around to get them to create more strength. So we reduce the interconnected voids. We're going right down the middle of the chart now. We're going to reduce the infiltration of air, water, mud, anything else, which is going to give us long-term durability. And then it relates to pavement performance. Going off to the right, you say, well, we want to make sure that we have good particle friction so that those particles will stay locked in place. We want to make sure that we have that good shear strength, which also then relates back to good pavement performance. And going down to the left, cohesion, by forcing those particles closely together, that will give us our lab strength, or what was designed in the lab as strength. And again, pavement performance. You can see the three parts of the scale there. Everything goes back to pavement performance. So how have our paving and compaction processes changed in the last 20 years? Well, they're ever changing. And I was just at a event in March, the World of Asphalt, and I'll show you in this picture, um, and I'll point out what I'm talking about. But you can see in the top left there, the old pull behind pneumatic tire roller, the one in the top center, a home built pneumatic tire roller, the old green steam wheel rollers. Then you get the more modern equipment right there in the center of the page, the Bomag rollers, the big cat roller. You have that drum roller on the back of a motor grader, and then that thing in the middle and the bottom there. That's a brand new piece of equipment that just come out, and that is a density detecting device that is made by HOM, or Wirtgen, the Wirtgen Corporation, HOM, and they're on the HOM rollers. But it is reading real time density. The two you see are the cat roller and that Bomag roller. You see the yellow one, the bright yellow one, and the dull yellow one. Those ones have what's called IC, or intelligent compaction, on them, where it's monitoring the resistance in the mat. But this new HOM one is the first one that's come out that's actually measuring density, and it has to be correlated with a nuclear gauge or cores. They run over it, and you have to do it 3 times, and then it will correlate, and it reads actual density. So that's a very new concept. It's a very new piece of equipment. So other things that we're seeing more and more now that we didn't see even 20 years ago, was the night paving operations. Night paving used to be kind of a one off, two off kind of thing. Now night paving is becoming more and more mainstream. Um, with that, we're seeing more SMA go down. We're seeing SMA at night, which creates a little bit of a problem. SMA, in order to get SMA compacted properly, you have to have plenty of heat. At night, we lose heat. Um, it's hard to see asphalt going down at night because black and black, dark at night. It's hard to see flaws. It's hard to see missteps. It's hard to see things that are going on. So those are things that we got to look at. Other things you can't see during night paving: segregation, and you can't necessarily pick up the bumps and dips, the smoothness issues. But smoothness is a high priority on all roads, whether it be a state highway, an interstate highway, a city road, a collector, an arterial, or a residential street. Keeping the roads with lack or low segregation and smoothness is critical for the long-term life of the road. And that's all part of what we need to do in our compaction process, is not create problems through the compaction process. So how do we do that? Well, training. We want to make sure that we have our operators and our other personnel on the project properly trained. We want to make sure they understand what they're looking for. We want to make sure they understand all the ins and outs to what is going on, to make sure that we're not going to have or create problems through the placement and or compaction process. So we want to make sure that we have our people get the best knowledge that they can have. And that's why many of you are here today, is you're trying to increase your knowledge. Staying in the night paving thing. Night paving, used to be they would pave by a candle and a flashlight. In today's night paving world, the light plants, the lighting specifications are crazy. How much light they have out on these plants to make them very visible. And then that last point is the compaction issues. And I talked a little bit about that, but the compaction issues at night, because the mat cools down quicker, especially when you're using a polymer modified mix, there are things that we have to adjust to at night that we wouldn't do during the day. So the slide I've got up there now is showing you a cold slug right in the middle of the mat. So you got the red, which is the hottest, the higher temperatures. Then you get down into that yellow and green. You can see it's in that 270 to 250 range. We got a cold slug right in the middle of the mat. How does a contractor know what to do to attack that cold slug in the mat? Well, the short answer to that is they probably don't even realize it's there. I mean, that's the short answer. They're going to run through that. That's probably either at the beginning of a truckload or at the end of a truckload. And they don't even realize that it's there. Not unless they have some sophisticated equipment, which I will talk about here in a minute. But you can see a view of another cold slug in the mat, which is basically the same cold slug. But you can see at the top of the illustration there, at the top of the picture, that's the paver. So you can see the people standing on the paver, and you can see the back of the paver. So that's something that has to be really looked at. I've titled this slide "End of Load," but it could be the end or the beginning of a load. Both of them are going to end up with the same thing. And then if we get a cold end of one load and a cold beginning of the next, we're going to modify this, or we're going to double up what size that is. How does the contractor and or the personnel on the site, the city inspectors, the county inspectors, the state inspectors, the other personnel, the testers, how do they know that that's there? Well, you have to have equipment in order to figure this out. So a good quality mat, you can see that consistent all the way across the mat. It's going to help in the compaction process. It's going to help to make sure that when they set up their roller patterns, they'll be able to roll it in a good, even pattern all the way across, up and down the mat. So the whole goal here is to roll for quality. We want to make sure that we have the proper equipment. You can see I've got pictures of all kinds of different equipment here. The upper right there, the little Lee Boy 7-wheel roller. You don't see many of those except in the small parking lots or small pavements like bike paths, those kind of things. Then you have the big boy rollers, the other three pitchers with the big boy rollers that we'll use out on city streets, highways, byways, airports, those kind of things. Construction of quality pavements, if those of you who were on last week should have seen this same slide. It is a balancing act between the production, the trucking, the paving, and the compaction. The problem with all of this is the first three can change: the asphalt production, the trucking, and the paving. Those can change at a drop of a hat. We can increase our production. We can increase the number of trucks. We can increase how many tons are going down. But if we don't adjust the compaction process, we could lose everything, and we could lose it very quickly if that is not adjusted. So it's important to make sure that everything stays in balance. If any of the first three change, the last one's got to change with it. So the goals for compaction, and what are we trying to accomplish, is we want to be able to put the material down that it will outlast the design life. Design life on pavements today, depending on what you're doing, a new pavement, you would expect it to last anywhere up to 30 years of total life. That's for the entire pavement section. The sub base, the base course, and the pavement section should last 30 years or greater without having to rebuild. Now, with that said, there are other things that we have to take into consideration. We have to do our regular maintenance in order to make that happen. So we want to make sure during the initial construction phase that we get it fully compacted to increase that load bearing capacity. If we expect it to carry this kind of load, we want it to carry even more. So we want to make sure we get it in properly. We want to reduce the air void content. There was a long period of time where we thought that having 4 to 6% air voids was ideal or optimum for the long-term life of a road, because it gave us that flexibility that asphalt will give us. Well, we found out in recent times that that isn't necessarily true. What we need to do is close those voids up. We need to close those voids up to keep the moisture out. We need to close those voids up to keep the oxidation from happening. So we want to tighten up those voids. Designed right now, design values we're seeing down as low as 1% air voids. That's a very specific mix that's being done. First one in Colorado is going to be done next year in the Region 3 area, which is between Rifle and Grand Junction. They're going to do a big job in there with a 1% air voids mix. We're seeing a lot of spec changes where we're seeing now the density spec has been increased up to 98%, and that will get us down to 2% air voids at time of construction. So those are things that we've got to be looking at. Well, we're going to reduce that air void content, which means we're going to have to put more energy into the compaction. Does that affect our smoothness? Well, it could. It shouldn't, but it could if people aren't paying attention. We want to make sure we increase the resistance to rutting and cracking. That is coming through a process called balanced mix design. And balanced mix design is on the forefront here, and it's where we are moving in our asphalt world. So our designs are all going to be done, excuse me, our designs are all going to be done using the balanced mix design method. And balanced mix design will give us a crack number that the material will have to pass a cracking test during the design phase and then during construction. And it will also have to pass the rutting test. Excuse me again, to make sure it won't rut under traffic. So it will pass both those things. What that's going to do is balanced mix design is going to change the amount of binder that we see in mixes. What we've seen already is that anybody that is trying to run a balanced mix design, they're having to increase the amount of binder by 2 to 4/10%. So nearly 0.5% more binder in, which is going to make it softer, which is going to resist that cracking. The other thing we're seeing is higher use of wrap. With balanced mix design, the designer can design in more wrap and make a more ecologically friendly mixes because we're using more recycled product in it. So the fifth bullet point there is increasing the life cycle costs, which is less maintenance. We close up the voids. We get higher density. We're not going to see the wear on it. We're not going to see the water and oxidation damage. So we're going to increase the life cycle costs by not having to do the maintenance, as much maintenance on it for potholes, crack sealing, those kind of things, because we're going to take care of that on the front end. So the compaction process can affect all of those things. Those are things that we have to be looking at. Variables for compaction. Eric, question popped in. How many municipalities are replacing all pavements on a 30-year life cycle? That would be absolutely none. What funding constraints? It feels like we need 40+ year payment cycles. Early failures are extreme, Eric. It's hard to predict. I talk from where I'm sitting in my office right now. I'm looking out on the road right here. I'm in my home office this morning, and I'm looking out on the road right in front of my house that was repaved this year. Um, the road was built in 1973, and this was the first overlay on it. They did one intermediate treatment in 2008. They did a slurry seal on it in 2008, but this is the first one that's been done. So it was what, 47 years that this road had lasted. So I think what you're saying is that our engineers need to figure out how to design to 40 minimum. They just haven't got there yet because they're the engineers. You being an engineer, they're always looking at that factor of safety. If I say it's a 40-year design and it only lasts 35, what they're going to come down on me. So I agree. It's impossible to predict an early failure, and it's costly because once it happens, you have no budget for it. Well, where you guys are at over there, you have an unlimited budget. I say very facetiously, just like any city or county or state. There's not enough money to maintain the roads as you have them right now. So it's virtually impossible. So yeah, I agree. If we could figure out how to just make the designers get to that 40-year, and I think that my opinion, and a dime won't buy you a cup of coffee, but my opinion here is that with balanced mixed design, we're going to see our roads lasting longer. You and I, in our careers, we're not going to see these roads last out to 40 years. But I believe that with balanced mixed design, that is the movement that we're going to see. We saw from Marshall Mix Designs where they were 20-year design life. They went to Super Pave and said, well, we can go to 30-year design life. Now I think going to balanced mix design, it would be simple to say we can get a 40-year design life with proper maintenance. And you know as well as I do, all of you on the call here today know that it's cheaper to maintain than it is to rebuild. So if we can just figure out how to create that maintenance cycles to keep our roads in good condition for 30, 40, 50 years, that's where we're going to be. So long-winded answer, but it was a great questions that I could jump off and go on a side road. So some of the things that we've got to look at when we're doing this is what materials are we using, and getting the right materials is key to keeping a long lasting road. And it goes back to that discussion there just a second ago. But if you don't pick the right materials, you don't get the right mix design, you're going to have a problem. And one of the things I see frequently is residential roads, lightly traveled roads being over designed. Even on the CDOT system, they're over designing the highways. And that's why we're seeing so much cracking, because they're overbuilt for the amount of traffic, and it doesn't have enough traffic motion on it to keep the particles together. So they crack. So we got to make sure we're using the right materials. We're looking at what are the weather conditions. Paving on top of Vale Pass is completely different as paving in Lyman or in Grand Junction. We got to make sure that we're mixing all of our components, A plus B plus C plus D. So the next one is the base condition. We build on a soft subgrade, we build on a soft platform, the road is going to fail. We want to make sure we have a good platform. The next one is the monitoring tools. How much are we monitoring what's going on? And what are the tools that we're using to monitor? Is it simply a nuclear gauge or a core rig, and we got all the lab tests out of the lab during the design process and during the production process? Or is there other things, like I showed in a couple of those pictures before, the infrared camera images, so that people can look and go, oh, there is a cold slug. After they change trucks, can somebody take a picture like that, use an infrared camera, and see that there's a cold slug there, so that they can attack it with the compaction process to keep it from becoming a long-term issue? That's being taken care of right up front. Um, the next bullet point is the type and quality of the machinery. Good, well-maintained machinery that has all the proper gear in it. They have the scrapers and mats on the rollers. The water spray systems are working. The release agent spray systems are working. The tires in the rubber tire roller are properly inflated, and they're all set up the same. That's in the machinery setup and calibration. So we want to make sure that we have all of that stuff done. And then the last one is, it doesn't matter how good your equipment is or how good the 6 steps above are. If your manpower is not uh, sufficient, that you're having people to jump off of one piece of equipment to get on another, or you have people on pieces of equipment that do not understand the equipment, the competency is low, you're in a losing situation. We want to make sure that we don't get into that losing situation. I talked about Super Pave. I talked about Marshall. I talked about where we're going with balanced mix design. Balanced mix design is just another evolution of Super Pave. Going to do them with a little bit different twist. So Super Pave is an acronym for Superior Performing Asphalt Pavements. It's a superior approach for going after what we were doing pre-Marshall. And I'll talk a little bit more about that. But so Super Pave really took us out of, and going back to the question that was asked a little earlier about 20 and 30-year designs. Well, when the interstate highway system was started in 1956, it was designed to last 30 years. Well, Super Pave started in the early to mid 1980s, because our interstate highway system had reached its 30-year design life, and they were looking at it going, what do we need to do? Well, that's why they came up and said, we got to do things differently, and came up with Super Pave. You know, prior to Super Pave, Marshall was, we can use whatever materials you got, wherever you got them, we'll make a road and make it last. One type of binder, and it all works. Well, yeah, it was great for nearly, and still around. We're still using Marshall 100 years later, but it wasn't the cat's meow. And Super Pave was never designed or never intended to end. It was intended to be a continually evolving process. Kind of got stagnant with it. We said, oh, everything's doing great, let's just leave it alone. And here we are now, nearly 30 years later, 40 years later, and we were still stuck in the same spot. So that's why everybody's starting to look at this balanced mix design now, which is the next step or the evolution of Super Pave. So what are the contractor's goals when he's out paving a project for any of you owners or agencies? They want to make sure they get the density. They want to make sure they get smoothness. For them, that all equals quality. The biggest challenges, and you can read this quote here, the biggest challenge for Super Pave is in training the people. Everybody on the project takes part in it. Communication among the lab people, road people, and the plant people has to be consistent. So that's just that's a very old quote. I've had it around for years, and we want to make sure that, you know, everybody is part of the process. I talk about teamwork all the time in classes that I do, and it's important that everybody be part of the team. It doesn't matter if you're on the contractor side or the owner's side or whatever side it is. There are no sides when we're on the project. We are a team, and we got to work together. So I talked about just a minute ago, um, the binders used to be one binder. It was one binder. You either had, in Colorado, we had AC5, AC10, AC20, and AC20R, but you picked one. Which one is going to work for me? Well, AC5, they used a lot in the mountains because it was lower temperature binder. So meaning lower uh, ambient temperatures and the freeze thaw cycles. But down in the plains, they were using AC20, AC20R. AC20R was a rubberized mix. AC20 was the standard. That was the mix binder that went in almost everything, AC20. But we went to PG, performance graded. The first number is a 7-day temperature, and you can see it's 64 or 147 Fahrenheit. And the second one is the minimum pavement temperature, which includes the negative symbol, negative 28 degrees Celsius or negative 18 Fahrenheit. So that's the minimum pavement temperature, single coldest day ever recorded at the weather station. And then the other one is the 7-day average highest temperatures recorded at the weather station. There are weather stations all across the country. You can go on the NOAA website or ltppbind.com and pop in a zip code, and it will show you every weather station that's within that zip code. It will then tell you on the LTPP bind site, it will tell you what is a 50% reliable binder and what is a 90% reliable binder. So you can look at that. That doesn't mean those are the right binders either, by the way. If just because it's 50% reliable or 90% reliable doesn't mean it is necessarily the right binder. We see people over specifying binders all the time. It'll say, well, this is the 90% reliable, so we're going to use that one. Say PG 64 minus 22. Well, it's a lightly traveled residential situation. You might want a softer binder, like a PG 58 in a residential, lightly traveled situation. So, moving on to compacting. The difficulties that we see are more crushed aggregates, less fines that don't create that lubrication. The fines hold the oil, which creates the lubrication to let the particles move during the compaction process. So the more crushed particles there are and less fines, it's going to become a problem. Cheating the binder out of the mix, but lower asphalt cement content or lower binder content. The binder, again, is a lubricant. And if we cheat the binder out of the mix, we're not going to be able to lubricate the particles and let them move by each other. That is why moving to balanced mix design is becoming more and more and more of a top shelf issue, because we want to make sure we have that binder in there that we can keep the particles moving to resist the cracking, but not let it rut. So we're going to work through that, and we're going to get there. Temperature is ignored. And this is 2 or 3 temperatures that we can talk about. The ambient temperature, which is really irrelevant, the mixed temperature, which is really a driver, and the ground temperatures, which is a driver. The two drivers, the ground and the mixed temperature, are critical to be looking at when we're paving. Ambient temperature is irrelevant. If it's a cold weather day, ambient day, and the ground temperature is sufficient and the contractor has temperature in the mix, there is no reason that they should not be able to place the material properly and get it compacted. It's going to require a change in thought, a change in process. If it's a cold day and I'm the owner or I'm the contractor, I'm going to have my testing people on site the minute that material starts coming out of the back of the trucks into the paver, and I'm going to make sure that when the rollers are on it, I'm getting density in that first truck, the second truck. I'm going to make sure that we are going to do what we need to do. Do we have to tighten up the rollers? Do we keep the rollers closer to the paver? Are we staying within the compaction temperature zones? Those things are going to be looked at. So if we drop out of those compaction temperature zones, that's when the temperature is being ignored, and we can't do that. So 2 things tied together. I kind of got a little bit ahead of myself, but the compaction zones are ignored or forgotten. That's a critical error in getting material compacted. Lift thickness, 3 times the nominal maximum particle size. If you go less than 3 times the nominal maximum particle size, you have the potential of crushing rock internally that you cannot see. So it will be crushed internally. Those particles do not have binder or glue on them to hold them together, and the road will start or potentially start falling apart from inside out. It's like on a car, all of a sudden you see rust all over your car and you go, where did that come from? I never saw it. Because it rusts from the inside out. This is the same thing, that the particles are crushed internally. They don't hold up through traffic and weathering. They fall apart. You start seeing delamination. You start seeing the last bullet point here is, if your equipment setup, if the contractor's equipment setup is ignored, they've got to make sure they set their equipment up properly, that they've got the water spray system on the steel drumlers, that they've got a good drip system on the tires, on the rubber tire rollers. They got scrapers and mats on both of those, that the paver is set up properly. Everything has to be set up properly. We know there are still a lot of holes in the science, but it's important that every person on the team be out there to help plug the holes. And it's not, well, you need to do this, you need to do that. No, it's need to have a discussion. Why is that happening? What did go and what went wrong here? What can we do differently here? What are those things? We have to understand the appropriate things to do. So these 5 bullet points here. What is the appropriate compaction temperatures? I say this all the time. I lead the inspector certification, asphalt APM, asphalt paving materials inspector certification sessions. And I talk about this all the time. The appropriate compaction temperatures for any project should be determined right at the beginning of the project, whether it's a residential overlay or it's an interstate highway. On interstate highways, state and federal jobs, you have to do what's known as a CTS, or a compaction test section. Residential paving, you rarely see anybody do an official compaction test section. However, the first day they are paving on the project is the compaction test section. That will set up the appropriate compaction temperatures. When does the breakdown roller get on? When it's this temperature and he's done by this temperature. The intermediate roller gets on when it's this temperature and he's usually done by this temperature. And the finish roller, same thing. How many passes? Are they in vibratory or static mode? What are all those things? It doesn't have to be anything that is official, or, oh, we're going to set up this area and do it here. No, it doesn't have to be that. It has to be, somebody has to be out there paying attention to what they're doing and documenting it so that it can be done. When they start having problems, you can look back and having problems. This is what was being done. And now we're having problems, and this is what they're doing. You think the two might be related to each other somehow. Maybe we need to get back to this one and away from this one so that we don't have we can try and solve our problems. So the compaction procedures in the field have to be defined and they have to be documented. The operator needs to be consistent. If it's 4 passes, 5 passes, 6 passes, vibratory, whatever it happens to be, that's what it needs to be all the time. One of the things that I find amazing on paving projects is that they're paving all day long. The finish roller's back several hundred feet, 1,000 feet, whatever, and the paver stops, and all of a sudden that finish roller catches them within a very short period of time. How did that happen? All of a sudden that consistency, because everybody else was done, so now he wants to be done. The operators, oops, sorry, I got going too fast. Go backward. The operators need to have the ability to provide quality. They need the tools. Do they have the right monitoring tools? Do they have an infrared heat sensor? Do they have or just a laser temperature gun? What do they have? What tools do they have to make sure that things are being done? And then understand the difference between a highway process, a city street process, a collector process, and a commercial parking lot. They're all different. This is just a bunch of temperatures that I threw in here. This is years and years of gathering data. So the material leaves the plant between 350 and 270 degrees. Well, depending on the type of material, some of you are saying, man, I hope mine's not coming out at 350. Well, if they're doing SMA, it might be. If you're doing a dense graded mix, 290, it's probably about where you want it to be. You don't want it to be anything over 290. But That's where we're at. The next 340 to 315 placement occurs. Well, that's on SMAs. Again, if you're coming out of the plant at 290, it's going to be pretty tough to put it down at 315. So it's gonna be down. Um, Compaction range from 340 to 110. And okay, I'm seeing some of you, figuratively seeing some of you, your heads are shaking and your eyes are wide open. I say 110, yeah, 110. You can compact down to 110 degrees. However, with that said, everything has to be done correctly, meaning that they probably, not probably, they have to have put in a workability mix additive or a WMA. If they don't have a WMA, they should probably be off the mat by no less than 160 degrees. You can keep compacting, but it's important that somebody be out there monitoring that. And if it starts to crack, you get fine little cracks across the mat. It's too cold. It's breaking apart during the compaction process, meaning that the binder has lost its cohesion and it broke apart and you're creating all those little fine cracks that are going to allow for oxidation and moisture damage to occur. So it's important that the inspector on the project or somebody be out there watching for that if they're paving it or they're compacting at lower temperatures. If they roll down and you get a little crack and they roll back, that means it still has enough heat in it that they're okay, but they need to make sure that they're all constantly closing up those little bitty cracks. Um, some mixes might have a tender zone between 250 and 190 degrees, but the typical compaction range is like 310 to 175. Can go down to 160. Again, with WMAs, you can get even colder. Uh, if the mix is too hot, it's going to roll, it's going to bubble, it's going to push, it's going to, there's lots of words we can use here, cause waves. We want to make sure we're not getting on it too hot, we're not letting it get too cold. So it's important that the mix coming out of the plant is the proper temperature and that it's being put down at the right temperatures. Compaction at 240 and above is recommended for breakdown and intermediate. Finish rolling, obviously, they want to let it get down to a point where the binder is going from its liquid to its solid state, and you're just above that point. You want to finish it just before it goes from liquid to solid. So if the temperatures are too low on a conventional mix design, well, I really blew that misspelling. Convection mix design. Um, we want to make sure that the mix will work on those things. So conventional mix design, if you get below that 175, it's going to be tough to get the material to compact. That 110, 120 with the WMAs in the mixes. But it's important that once they drop down below that 170, 160 range, that the inspector or other personnel are out there watching to make sure that they're not causing damage to the mat during the additional compaction process. Um, the effects of ambient temperature. Um, again, I talked about it being irrelevant a little bit earlier, but it has to be monitored. It process to get it to compact in a sufficient manner and get it to give us our life. So the necessity of that is that we got to make sure we are monitoring the situation, the contractor's monitoring the situation, all the team is out there looking at it and make sure that we get everything done in a smooth and efficient manner. 4 ingredients for compaction. The first one is static pressure. That's simply the weight of the machine. Too light a machine, hard to compact. Too heavy a machine, over compact. Vibration. Uh, those are vibratory steel drum rollers. Oh, I've got a couple things coming in here. Hang on. Looks like disconnected and reconnected. Now the slides aren't showing. I'm the only one. We can no longer see the slides. Uh, Trying again. Are we back on? You guys let me know. I've got one that says effective ambient temperature up. Somebody let me know. No slides yet. Why did it disconnect? Ay, ay, ay. Going along fine. You can still hear me though, right? You can see my camera? Yes? But no slides. What the hell? Effects of ambient temperature. Let me know where we're at. Does anybody see it? No slides yet. What? Let's try this again. Hang on. Stand by. Let me connect back up again. Back up. There it is. Sorry about that. I don't know what happened. Hey, the internet monkeys jumped in. So let me move on. I don't know what you guys saw last, but I will keep moving on. Um, all right. So I talked about the different pressures. Let me go back. So static pressure, vibration, impact, and manipulation. Those kind of things are what we got to be looking at. The weight of the roller, the simple weight of the roller. A small roller on a 3-inch mat or 2-inch mat may be a problem. So you got to make sure we have enough energy in the compacting equipment to get the density that we need. It's important that we have the energy available. So how do we increase the energy? Well, we put vibration in it. So we could have a small roller, but if we have vibration in it, that's going to increase the energy that we're going to be transferring from that machine down into the mat. So if we get that energy pushing down into the mat, then we can get the compaction. So the vibration is caused by a shaft in the center of the drum that is spinning, and it's got weights in it that are throwing the drum up and down. And I think I got in the next picture here. Yeah, 4/100ths of an inch. So if you're standing back watching it, you ain't going to see it. 4/100ths of an inch is much, but you can see it if it's not being done properly. So that's called the impact. That we're trying to impact or bounce that drum off the mat or increase that energy. The pneumatic tire rollers is a kneading action. You can see KNEEAD. It's kneading, it's pushing the particles from side to side. And since we have 2 sets of those wheels, it's pushing the material side to side and front to back. So we've got it going side to side and front to back. The pneumatic tire, the amount of energy being pushed through that pneumatic tire roller depends upon how much does the machine itself weigh, how is it ballasted, and then the next thing is the tire inflation pressure. If the tires are inflated low, meaning they have, let's say, 50 pounds of air in each tire, it's going to give you a much wider footprint, which is going to spread the ballast weight or the weight of the machine over a larger area. To where if you have a high tire pressure, say 105, 110, 120, you're going to make a very narrow tire, and it's going to push the weight into a much smaller space. So you're going to get a lot more energy on a wider tire than a narrow tire. Now, what's the deal? What should the tire pressure be? The tire pressure should be what it needs to be. There is no set tire pressure. If you have a very hard to compact material, it should be a high tire pressure. If you have a very soft or tender material, it should be a low tire pressure, but it should be adjusted for the material being compacted. Probably 90% of the time, it's going to be set just tire pressures. The key to this is there's 9 tires, and they should all be within 5 psi of each other all the time. The newer rollers that we see today have TPS on them, or tire pressure sensors, so that the operator can sit up and look at the tire pressures and make sure his tires are all in the right zone, in this, they're within 5 pounds of each other. They also have that they have little pumps now where they can air up and let the air out of the tires right from the operator's seat themselves. Is it a soft rubber tire or is it a hard rubber tire? The tire ply. And then that I talked about the contact area, that's through the tire pressures. So those are things that we got to be looking at to make sure that we get um, the good amount of ballast or energy into that mat. So I already talked about the reorganization of the particles. It's being done through the vibration as well. The vibratory roller vibrates and it has amplitude frequency going up and down, but it's also vibrating. So it's creating that motion as well. We also have the oscillatory rollers. There are several manufacturers now that make oscillatory. So they're not only going up and down, they're going up and down and they're going back and forth. So we're getting all the movement that we could look for. So the question you have to ask yourself is, how do you know when the amplitude is set either too high or too low? And so we'll just talk about the high part of it is you look for the material that's not staying under the drum. If it's being pushed out from under the drum, they're probably running on too high of an amplitude. You want to watch for white caps. That means they're putting too much energy into the mat. There's too much resistance at the base and it's fracturing rock. Fracturing rock means it doesn't have the glue on it anymore. So we want to make sure that we've got the material in staying in its production state. The impact spacing should be 10 to 14 impacts per foot. I'm going to show you the next picture and you'll see it's hard did not keep it at that 10 to 14 impacts per foot. And what that does, it's going to affect the long-term life of the road by creating chatter in the road, which is going to create vibration in the road as vehicles are going over it, which is going to break the particles apart. So it's important that you have the right number of foot. So if they're traveling too fast, the impacts are going to be too far apart. You want to make sure it's traveling at the right speed so that they're filling all the gaps. So this is that picture that I was just referring to, where you can see the light and the dark and the light and the dark in the picture, I hope. Um, but that was because their impact spacing was so far apart. You ride down this road, even in a vehicle, in a passenger vehicle going about 35 miles an hour, and it's going to hum. It's going to have a really high pitched hum to it. Well, that hum becomes energy, which creates vibration, which will break the particles apart faster than a smooth road will. That's why smooth roads are critical. We want to make sure that we're keeping the particles in place. This is a thing I hear from the roller operators all the time. And what I just talked about, their finish roller was 1,000 feet back. Now he's got to catch the paver. Well, no, that's not true. You got to stay within your zone. Whether you're the breakdown, the intermediate, or the finish roller, you got to stay within your zone. So, some compaction questions. I get this asked all the time. Does moisture change the mix characteristics? The answer to that is absolutely. Moisture is also a lubricant, but moisture in an asphalt mixture, because the asphalt is 250 to 300 degrees, depending on it, will turn the water to steam. Steam is a stripping agent. Steam will strip the oil off of the rock and it will bring it to the surface, and then the bubble will break and you'll see blotches of oil all over the surface, which means that the coating on the rock has changed, which means the glue that holds the two rocks together has been changed, and now we've lost our cohesion through that moisture and the characteristics of that what that moisture has caused. Will a tender zone exist? That is a really tough question to answer. Um, I have not personally seen a mix with a tender zone in it for years. Designers have gotten really good at designing around tender zones. So it could exist. You might see a tender zone in a mix, but it's been a long time since I've seen a tender zone in an asphalt mixture. Do PTRs, pneumatic tire rollers, pick up material? The short answer to that is not if they're done, not if it's done properly. They keep the tires hot and they have a good approved non-petroleum based release agent. they keep the tires hot, the release agent is on there, they've got good scrapers and mats, then chances are the pneumatic tire roller will not the material. If it does, you get the elephant globs or the cow pies or whatever you want to call them on the mat. It's just a matter of the contractor adjusting what they're doing, get back to what they should be doing, and getting back on it. This question is the unknown question. How much compactive effort is required? The short answer to that is just enough. The long answer to that is it's going to take time and effort to figure out what just enough is. I talked about that a little bit ago. Creating a compaction test area, compaction test section, whatever you want to call it. If you have that in place, you know that works. And if they all of a sudden are starting to struggle, or all of a sudden you see them, it was supposed to be 4 passes of the breakdown, 6 passes of the intermediate, 2 passes of the finish roller. All of a sudden they cut it in half. Now you might understand, wait a minute, we got a problem. Get the density gauges out there and figure out, did they cut what we need to do? We need to make sure that our compactive effort is consistent. That's for going back to the question that was asked very early on about 30 and 40-year design lives. If we're consistent from curb to curb, edge to edge, end to end of the pavement, it's going to be a lot easier to maintain and figure out a maintenance plan than if we have things that are all over the place. If we have stuff that is all over the place, we are in trouble. We got to make sure that we have the right amount of compactive effort that is consistent to get the job done. Can overrolling cause crushed aggregates or bleeding? I've already said that. You go back up to earlier where you get white capping. Overrolling it means it gets too dense. It will start crushing the aggregates, and it will start creating more internal problems. Bleeding is probably not a problem. We're not seeing enough oil in our mixes. Excuse me, that even overrolling it is going to cause bleeding. So it's important that the roller techniques be followed in a regular and consistent manner. It's important that rolling techniques be observed. It's important that rolling techniques not just be, oh, well, those are the as important, if not more important, than the paver operator. If the paver operator does his job, the roller operators don't do their job, the whole thing falls apart. If the paver operator screws up, the roller operators at times can fix it. But if the roller operators screw up, the paver can't fix it. So the roller operators are the guys on the back end that can make things right, even though sometimes they might not be on the front end. You have excessive handwork, you have other things going on. So, question here, is keep it smooth and roll it right. So, rolling joints. There's 2 schools of thought here. I have always been in the school of thought you roll from the hot to the cold. You pinch on the hot side, and then second pass you go back and you roll on the cold side. So here, cold. Sorry, my phone started talking to me. Cold to hot, hot to cold. Hot to cold, pinch off 6 inches. You can see in the picture on the top left where that looks like a little bump right there on the joint. Um, that's the way it should be on anything. So they overlap by that inch to inch and a quarter, push it back and create that little bump. You pinch on the hot side, 6 to 8 inches, what you see on the bottom picture there, pinch on the hot side, and then you roll back over and you force all that excess material down into the joint. So that's um, the best practice. To pull apart, but we can do things to slow that down by the way we roll. So again, from the hot side, pinch, go back, roll over on the, and force all the material down into the, lost the slides again. What the hell? Let me bring them back again. I can do that. All right, back. I don't know why it keeps doing that. I'm sorry. Apologize. That's WebEx. I'm going to have to talk to them. Should be back on. All right. So hot side, pinch 6 to 8 inches off the joint. Have that extra material at the joint. Come back, overlap about 6 to 8 inches. Force all that material down into that joint to create that nice tight joint. Just another illustration, making sure we do that hot to cold. Another, I can't, so you see the little bump there, from a cold to hot, hot to cold. But again, hot to cold is what we're seeing today. Hot to cold is what most people are using. When you're edge rolling, roll 6 inches off the edge. It's on an unconfined edge to pinch it, then come and then go back out and roll completely out to the edge. The reason for that is that if the roller runs all the way up the edge, at the edge of your mat, you're not going to have your thickness. It's going to just push out. You roll, pinch off the edge, and then come back. If you're next to a curb or a confined edge, go ahead and roll right up to that edge because it's already confined on the outer edge. On a crown, we roll off the hot side onto the crown. You never want to, you want to roll from the low to the high side of the crown, so you don't push stuff down into the edge, into the outer edge. Transverse joints or night joints, ideally you want to roll them in the direction of traffic. However, that's 90% of the time that's not even possible. So we want to roll as best we can. You can see the red sticks or whatever you see on the screen there. Those are boards that are the thickness of whatever the mat was supposed to be, so they could roll off, take the drum completely off the mat. Again, that doesn't always happen, but again, I can make pictures and I can talk about the way it should happen and not necessarily the way it does happen. Rolling from the hot to the cold. This is, you're going to start on the cold mat, go into the hot and push back to the cold mat. Because if you push off of the cold mat, it's going to create a wave in front of the roller that you're going to get a little dip at your joint. So it's best to somehow get on the hot mat and push back to the cold mat. So if they have to go on one place, off the cold mat onto the hot, they go off, they come back and push, they come back in the same spot and push and keep moving over until they get the entire mat compacted, pushing back to the cold to get the best density that they can. So it's important. I've already talked about roller patterns, making sure that when they're setting those roller patterns, that the rollers are overlapping a minimum of 6 inches, that they're rolling however many times it takes to get across the entire mat. They don't stop at the same place every time, that they're stopping at a different spot to not create a one mark across the mat. They're running in different patterns, that they turn out when they get to the end, that as they're going along, they turn out so that they don't create a mark on the mat, that if they stop straight, that mark will never come out of the mat. It will always be there. It'll be something that will be a bugaboo to anybody that's got to do maintenance on that road forever. It's important that the roller operators stick to the roller pattern, making sure that even if there's free beer, that they're not running off. Vibratory compaction, the roller operator should never start or stop abruptly. They should start up slow down to stop. Vibration off before stopping and starting. Again, that's the older rollers. They had to manually do that. With the newer rollers today, they automatically will shut off when it reaches a certain speed. It will shut itself off. Steering that arc that I talked about. make those gradual turns, never vibrate while the machine is stationary. This is a good subject to talk about right here. Um, we know that a lot of times the paver will get caught up, so they have to stop. There's no trucks to feed the paver, so they have stopped. Um, then the breakdown roller will catch up, and he pulls up right behind the roller and stops. He stops on the mat straight, which I told you should never do, and he sits there, and it's in a vibratory mode. And I'm going, wait a minute, he doesn't have the vibratory switches on. No, but it's a big giant diesel power plant in there that's running, and it's sitting there vibrating on the mat. That roller should never stop behind the paver. If he gets caught up, he should back up to where the intermediate roller is, turn out, and stop way back there. Stop somewhere, but not right behind the paver. Maintain a proven rolling pattern. That's probably third or fourth time I brought that up now. Having that good understanding of what they should be doing. Once the density is reached, they should get off the mat as quickly as they can. They should begin the rolling or the compaction process at the highest possible temperatures. The more temperature, the faster it's going to happen. Joints are always compacted first. So, well, the operator himself is going to feel it. He's going to feel the vibration or the shaking in the machine. You want to watch for the white capping. If you're the inspector, you're a person on site, watch for white capping. Listen to the sounds of the roller. When they're rolling on a loose mat or a not compacted mat, it's going to have a completely different sound. The pinging, the tinging of the drums are going to be completely different. So what causes ripples? Again, amplitude and frequency not being right. What causes indentations? Stopping a roller on the mat in the not proper way. What causes long waves or line? Again, not having the right amplitude and frequency. What are two ways to balance the paver speed and the rollers? Well, it's set up your roller pattern, and they know that they're going to pave. The paver doesn't go fast, slow. They pave at a consistent speed so that the rollers can pave at can compact at a consistent speed as well. How many compaction zones? I hope you've all heard me say that there are 3: breakdown, intermediate, and the finish roller. 3 compaction zones. You still got 3 compaction zones. 1 roller, 3 compaction zones. 2 rollers, 3 compaction zones. There are 3 compaction zones on every project. Where, when does the material come out of the back of the paver? That's where you start monitoring density. From that point forward. So this is just the paving train. You have the breakdown roller, the intermediate, and the finish. What I just said, the 3 compaction zones. These are done in distance, in temperature, not distance. So the breakdown is done between whatever. I just put on here 330 to 270. The intermediate 270, 250 to 170. The finish roller 180 to whatever. But those are those are just numbers that I put on there. Those aren't necessarily what will be on your project. They won't necessarily be what will be on 2 projects in a row. But you have to make sure that they are working within those temperature zones and not distance behind the paver. Super pave train can be a little bit different. Super pave, if you've got a polymer mix or a tender mix, which we again haven't seen in a while, but polymer mixes, we don't see the 9-wheel rollers, the rubber tire rollers, because polymer and the rubber tires don't necessarily like each other. So we're going to see 3 steel drum rollers. You get 5%, 5 to 7% of the density during the breakdown and the intermediate, and then you get about 1% additional during the finish roller. The finish roller, let's chat about finish roller a little bit, and densities. So we're taking densities out there, and the density, that guy right there, and you see in the picture in the upper right there, he's taking a density test, and he looks up at the roller operator and says, nope, you don't have enough, or he writes on the mat, you're at 91. So then the finish roller turns the vibrators on. Remember I talked about just a minute ago that the finish roller is on it when it's 180 degrees or less, when the material is going from its liquid to its solid state. Turning the vibrators on with the finish roller just means you're breaking the particles apart. You are going to ruin a mat. Not, and I'm obviously saying you, not necessarily you guys on this session today. Operator is going to ruin the mat by breaking those particles. Will he get density? Absolutely. It's going to get density. It will densify, but will dollar question. Will it hold together for the long term? My guess is it won't. You're not going to get the 30 and 40-year life out of it that you're expecting. So the 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 finish roller, if you're an inspector or a part of a crew and you see them have the portion on the finish roller, they need to readjust what they did. Why are they now turning it on? Go back and look at the roller pass study or the roller compaction test section or whatever you want to call it that you did changed. Something changed that now all of a sudden they're having to put that vibratory on to get the density in the back end. So the technicians out there need to be working with the paving crew all the time. They need to make sure that that paving crew is kept in the know so that they can adjust if they need to adjust. The material got colder. We got to change what we're doing. We got to move our rollers up. We got to do something else. There's lots of things. So I talked about temperature monitors. Most everybody today has a laser type temperature gun. You shoot it at the grade and it spits a number out the back. There's two on the bottom left there, the Milwaukee and the FLIR. Those actually have a little cameras on them. I have that Milwaukee one that I carry in my truck when I'm out on projects, and I can take shots and I can actually see. It's an infrared. They're not very expensive. They're relatively inexpensive in the big picture, but it's a nice tool to have. There are actually apps now that you can use the camera on your phone and take infrared pictures. I haven't looked them up, so I don't know what they are, but I know that they're out there so that you can monitor infrared stuff on your pocket phone. Intelligent compaction, it's been around for a while now. It works off of GPS satellite stuff. There's an onboard reporting system. Today, we're seeing the PavIR system being used. It's an infrared scanner that scans the mat during the entire paving process. It's up on the paver and it's scanning the mat. It will actually look at the mat. It will relay information to whoever has the data collectors. That means there could be one on the breakdown roller, the intermediate roller, the finish roller, and it talks back and forth. The system works off of GPS. It works off of all kinds of things. This is the system when it was initially developed in 2003 in the upper left there. 2008, they moved it from being pushed behind the paver to actually being attached to the paver. And then in recent years, they've actually improved it even more now. They've got the scanner up on the top of the paver, so it's out of everybody's way. And it's a lamp that's rotating back and forth from side to side, and it's giving a consistent view of the mat. Again, that can be then sent back to the roller operators so they know where the hot spots and the cold spots are. It also monitors other things on the paver, systems of the paver. How fast were the augers turning? How many feet per minute were they paving? It's got a lot of data that can be collected off of this PavIR system. So as we're kind of getting to the end here, if you don't remember anything else today, remember compaction is in terms of temperature and not distance. Know what the mat temperature is at all times. Read the mat. I talked about when they're starting compact, listen to the drums, listen to the roller. It will change tone as it gets denser. It changes tone. Listen to it. Don't be afraid for the contractor to work with the contractor to make adjustments if needed. As temperatures change, so must the roller setup, so must what everything is. Cooler this time of year, they have to adjust. In the middle of the summer, it's an adjustment. Everything's going to spread out. There's a lot more moving. Know what the density is behind each roller operation. Getting out, it's important that after the breakdown, that the density tests are being taken so you know how much gain did we get from the when it was placed, the density goes down, then the breakdown, we got this much gain from the intermediate, from the breakdown to the intermediate, we got this much gain from the intermediate to the finish roller, we got this much gain. We need to know what they are from placement to finish. And that's in the early stages. Doesn't time. It doesn't hurt to do it once in a while, but it's one of those things. And with that said, you'll understand the big picture it better if you do know what those things going on. So some more questions here. Does getting more density in the breakdown position mean I could do less in the intermediate and finish zone? Yes and no. If you're getting more in the breakdown, then are you causing damage by doing that? Or did you overcompact it, which means you started causing fracturing? So you have to make an evaluation. Is the overcompacting and the breakdown causing damage? If it is, then no, don't do it. But if it doesn't, yes, you can change how much intermediate and finish roll are you doing. Should I use the automatic systems on the equipment? Absolutely. Their automatic systems are way smarter than any of us. So it's just a matter of monitoring, making sure the people on the equipment know what the systems are doing. Once I establish and follow a proper roller pattern, can I stop testing? No, you can stop testing as much, but it still needs to be tested because you're constantly needs to verify what's going on. So we've spent the last hour and 47 minutes, minor few little glitches there, and I don't know what's going on with that, but this to come down to this one statement, it's all up to you as inspectors, engineers, testers, paving contractors, whoever. Remember, I talked way earlier, an hour ago, as once we're on a project, we are not adversarial to each other. We are teammates. We need to work together to get the job done in the most efficient manner for the longest lasting road. So it's all up to you. Quality pavement and compaction must be your goal. With that, without it blipping out on me again, I'm all done. If anybody does have any questions, I would be happy to entertain those at this point. Hopefully I didn't lose everybody. Not seeing, I'm going to give you a second there to see if anybody's got any questions. If you do have questions that you think about after the fact, again, there's my email. You can get a hold of me, that my cell phone number on the screen. I will get this put up on the website as soon as I can. I'm leaving as soon as I'm done here. I'm heading to a CAPA Board of Directors meeting up in Estes Park. So I'm going to be up there for the rest of today and tomorrow. And then I'm at a conference Monday, Tuesday, and Wednesday. So I'll try and get it up as quickly as I can for you to pass along to anybody that might be interested in seeing it. So with that said, I'm going to stop sharing that screen. Appreciate everybody. Hope you have a great day. Thank you to our sponsors again. Y'all have a great day. Enjoy. Be safe.